Assalamualaikum everyone. Representing my group, I am here to tell you that we are fighting an unwinnable battle at the macro level. To truly solve this crisis, we have to look deeper, down to the atomic level. Welcome to our presentation, where we explore a revolutionary frontier curing plastic pollution with nuclear science. Plastic pollution is no longer just a visible eyesore. It has become an invisible microscopic epidemic. Recent research by the International Atomic Energy Agency, or IAEA, has confirmed that microplastics have now infiltrated the most pristine, untouched sanctuaries of Earth, from the deep waters of the Galapagos to the ancient ice cores of Antarctica. Now, let's look closer to home. Because of rapidly growing populations and overwhelmed waste infrastructures, nearly half of all global land-to-sea plastic leakage originates in Southeast Asia. Our beautiful rivers and coastlines have become the primary conveyor belts for the crisis. We cannot afford to wait for a miracle. We need an immediate, scalable, high-tech intervention that can handle waste volumes of this magnitude. 9%. Despite 40 years of global awareness, colorful recycling bins and community campaigns, only 9% of all plastic ever produced has actually been recycled. The remaining 91% sits in our landfills, incinerated into toxic gases, or leaks into our oceans. Why is this failure rate so high? It is due to the fundamental flaw called thermal degradation. Every single time plastic mechanically melted to reuse, its polymer chains are chopped up and structurally weakened. This is not recycling, it is downcycling. You turn a plastic bottle into a low-grade plastic bench, which eventually degrades and ends up in a landfill anyway. Mechanical recycling is a temporary band-aid on a terminal disease. The final location for plastic pollution is the ocean. New Tech Plastic understand this and combine science and technology to fight it by monitoring and assessing using nuclear techniques which track and study microplastics in the ocean, which then they inform decision makers. Using radiation technology, they transform plastic into useful products, and this is called upcycling. Next, nuclear and radiation had aided us with radio tracers to track and study how microplastics move in the marine ecosystem. Okay, sing with me. Baby shark, baby shark, baby shark. Plastic has made their way into baby sharks inside the mommy sharks, which then we consume. Safe to say, the word nuclear brings taboo, but radiation upcycling is incredibly safe. First, there are no residues. The process leaves absolutely zero lingering radiation, and the moment it is complete, the plastic is 100% safe to handle. Next, the facilities are shielded. All machineries is housed in heavily shielded rooms with automated safety shut-off to protect workers. And there is zero emission. There is an entirely dry process. There's no burning, meaning zero pollutants or dioxins are released into the environment. To see the advantages, we'll compare traditional thermal pyrolysis with radiation upcycling. First, emission. Pyrolysis releases high CO2 and dioxins, while radiation is a cold process with zero emission. Second, chemically, pyrolysis requires heavy hazardous solvents. Radiation is a completely dry process with none. Third, energy used to melt plastic are extremely high, but radiation uses highly targeted beam energy. And most importantly, safety. Traditional methods leave behind thermal residue, while radiation upcycling end product is completely inert and stable. We suggest the use of radiation technology in plastic recycling should be expanded. Technologies such as gamma irradiation and electron beam treatment can improve recycling efficiency and enhance the quality of recycled plastics. Second, more research and development should be carried out. Scientists and researchers need to develop safer, cheaper, and more effective nuclear technologies to reduce plastic waste and microplastic pollutions. Next, public awareness should be improved. Awareness campaigns can educate people about reducing single-use plastics, proper waste segregation, and the benefits of advanced upcycling technologies. Collaborations between organizations should be encouraged. Governments, universities, industries, and international organizations such as International Atomic Energy Agency should work together to share expertise, technology, and funding for better plastic waste management solutions. Countries also should develop sustainable waste management policies. Stronger environmental policies can support recycling programs, plastic reduction strategies, and the use of sustainable waste treatment technologies. Continuous environmental monitoring should be conducted. Nuclear analytical techniques can be used to monitor microplastics contamination in water, soil, and marine environments to ensure environmental safety and pollution are controlled. To conclude, nuclear technology has great potential to help solve the global plastic pollution problems. However, proper safety measures, continuous research, public awareness, and strong cooperation between organizations are essential for its safe and effective implementation. That is all from us. Thank you.